This is the second video for the problems, homework problems on page 358, and I'm going to jump right in with beginning with problem number 29. So in problem number 29, cosine theta over sine theta, I'm going to choose my u to be sine theta. It is in the denominator. I could pick cosine theta and see if that would get me anywhere. And if it did not get me anywhere, then I would back up and try again. The derivative of sine theta is cosine theta. That works out beautifully. There's my d theta. I'm going to make my substitution. So I end up with 1 over u du. There it is. So I get ln, absolute value of u plus c. Substitute in my u, which is in this case sine theta, plus c. All right, let's go up to the problem, to the next set, which are, now we're going to go to definite integrals in 59 to 55 odd. Beginning with problem number 59, I'm going to let u equal to the denominator of 3x plus 1. This is 49. And du is equal to 3dx. I do not need the 3, so I'm going to divide it to the other side, and I get dx. I have a coefficient of 5 that I'm going to bring to the outside by integral properties. I'm going to bring my 1/3, so I divide by. I'm going to end up with 1 over, I'm replacing 3x plus 1 with u, and the dx with the du and the 1/3 that's already there. Now I'm going to change my bounds, so a 0 in terms of x becomes a 1 in terms of u, and a 4 in terms of x becomes 12 plus 1 is 13 in terms of u. I'm going to find the antiderivative. There's my coefficient of 5/3, ln, absolute value of u. No plus c in this case because we have a definite integral, which is 5/3 times ln of 13. Now notice I didn't put absolute value because the absolute value of 13 is 13, minus ln of 1, and the ln of 1 is 0, so I end up with 5 ln of 13 over 3, number 49. Number 51. I'm going to let u equal to my inside function of 1 plus ln of x. So let me clear that off. So for 51, u is equal to 1 plus ln of x. du is equal to, the derivative of 1 is 0, the derivative of ln x is 1 over x dx. So that's going to take care of that x in the denominator. I'm going to make my substitutions, and that will simply give me u squared du. My 1, I'm going to change the 1 into ln of 1 is 0, and 1 plus 0 is 1, so it stays a 1. I'm going to substitute e in place of x. The ln of e is 1, and 1 plus 1 is 2. I'm going to anti-differentiate, and that becomes u cubed over 3 from 1 to 2. Substitute the upper bound. 2 cubed is 8 over 3. That's upper bound. Substitute 1. That's the lower bound. 1/3. And 8/3 minus 1/3 is 7/3. Number 51. In number 53, I am going to, let's see, I think I'm going to do long division. Is there anything else that I want to do? Remember, it's all about looking at strategies. I have a larger power in the numerator than I do in the denominator. So yeah, I think I'm going to go with long division because the numerator doesn't factor. So x plus 1, x squared plus 0x, there's my placeholder, minus 2. X multiplied by what will give me x squared, and that is x. So I'm going to put that over the x. I'm going to multiply. X times 1 is x. X times x is x squared. Subtract, and the x squares subtract out. 0, be careful, minus x is negative x. Bring down the minus 2. X multiplied by what gives me negative x? That's negative 1. Negative 1 times 1 is negative 1. Negative 1 times x is negative x. Subtract. That subtracts the x's out. Negative 2 minus negative 1 is negative 1 because that's negative 2 plus 1. So my new integral now becomes the antiderivative of x minus 1 dx and minus, so here's that remainder, minus 1 over x plus 1 dx. Remember, it's remainder over divisor. Now, in this time, I'm not going to go into u sub because I can do this problem completely in terms of x. So I am not going to change my bounds. I'm going to keep the 0 and 2. So here's the 0, here's the 2, here's the 0, here's the 2. Antiderivative, x squared over 2 minus x evaluated from 0 to 2. The antiderivative of 1 over x plus 1 is ln, absolute value of x plus 1 from 0 to 2. Upper bound minus lower bound for each one. So 2 squared is 4, divided by 2 is 2, minus 2, that is the upper bound of 2 going in, minus the lower bound, so that's just going to give me 0 minus 0, and 2 minus 2 is also 0. That takes care of the first term. For the second term, same thing, upper bound goes in, and I end up with ln of 2 plus 1, which is 3. Substitute 0, upper bound minus lower bound, ln of 1, which is 0. So this is a 0, this is a 0, this is a 0, so I end up with minus ln of 3. That's number 53. Moving on to 55. In number 55, I'm going to let u equal to the denominator, let's see if this works, of theta minus sine theta. The derivative of u is du, the derivative of theta is 1, and the derivative of sine, perfect, is cosine, and that's exactly what I have in my numerator. I'm going to make my substitution, so my new integral becomes, in place of 1 minus cosine theta d theta, I can substitute my d theta. In place of theta minus sine theta right here, I can have my 1 over u. I'm going to change my bounds, so a 1 substituted, now be careful because you got to substitute here and here. I'm not sure I'm going to want to do that in this case because I'm not going to be able to find the sign of 1, but if I do it, if I go back, would that make it any easier? Let me think about that. Well, let's just go ahead. So a 1 becomes a 1 minus sine of 1, and a 2 becomes a 2 minus sine of 2. Now, no, you do not know the sign of 1, nor do you know the sign of 2. Remember, that would be 1 radian and 2 radians. So don't be afraid of those bounds. They're legitimate bounds. They're legitimate numbers. We just, without a calculator, we're not going to be able to do anything with them. So we're going to keep them as exact values. I'm going to do my anti-differentiation, so I get ln absolute value of u evaluated from the low bound of 1 minus sine of 1 to 2 minus sine of 2. I'm going to substitute the upper bound, so I have ln absolute value of 2 minus sine 2. And since you don't know whether that number is positive or negative, keep it in absolute values. minus the lower bound, ln of 1 minus sine of 1. Keep it in absolute values since you don't know whether that's positive or negative. Now, I am going to tell you that because of this minus, remember log properties. So if I have my log properties, log base b of a minus log base b of c is the same thing. Remember, we can condense our logs when they have the same base to be log base b of a divided by c. So this could be written in a multiple choice scenario as ln of absolute value of 2 minus sine 2 over 1 minus sine 1. Just be aware that that's how the answer could be written, using log properties. That's number 55. And since this is not a calculator set, you just leave your answer in exact format. All right, the other two are, let me scroll up here, 63, and I don't have 64 in my flip chart, but I will find that problem in just a minute. So in number 63, we are finding the derivative of a definite integral. So remember, when you're finding the derivative of a definite integral, slow and easy. Take out the dummy variable of t. So this is what it looks like. Remember, I don't have to go through the whole process. So take out the t. I'm going to put parentheses for emphasis. Step 2, substitute the new function. So the new function is x, and I'm going to substitute it here. When I take the derivative, I take the derivative of x, not of 1 over x. The derivative of x is 1. So the derivative is 1 over x. All right, let me bring up number 64. So 64 has magically appeared on our screen, and we are doing the same thing as we did in 63. We're finding the derivative of a definite integral. So the derivative of big F is f prime of x. When I find the derivative of the definite integral right here, I'm going to, step 1, take out the dummy variable, take out the t. Step 2, put in the new function. In this case, the new function is plain x. Step 3, multiply by the derivative of the new function, and the derivative of x is 1. I'm not taking the derivative of tangent. I'm taking the derivative of the new function only. So that just simply gives me tangent x as the first derivative. So hope this has been helpful. Let me make sure I have covered all the problems, and this is the second video. Yep, I think I've covered everything, so I hope this helps you.